So, welcome to LiveDataPro. My name is Anup Surendran. I am your moderator for today. I'm also the head of product marketing at Pathway. Our objective with these webinars is to make you, our audience, experts in processing real time data and finding insights. I hope we will do a quick introduction today, then I'll pass on to Bober. But at a very high level, Pathway is a source available package which processes streaming data, batch, and Gen AI data. Since Pathway is a unified platform, we can take data from the left-hand side, as you see on the top left. You have event data all the way from event data to unstructured data. And it can do complicated things with this data. It can do fusion really fast. And talking about fast, we have a benchmark slide we'll talk about very soon. And when you do fusion data, an example would be taking in sensor data, fusing it with geospatial data, and creating these amazing real-time dashboards. Uh, After that, or in this pipeline, as you see, you would see a vector index, you'd see a real-time index, both with structured and unstructured data. And the value developers can quickly get out of the system are easy to build anomaly detection software, real-time machine learning, and last but not the least, graph analytics, which is all built in within the platform. And the blue box on the right-hand side talks about how you extract data. So you could do SQL for those developers who are not really familiar with different types of coding platforms like Python. You could do simple SQL. You could have REST endpoints, and you could plant in a natural language interface like a chat interface. And this platform has anomaly detection, so you could do alerts and pre-configure alerts for your business. That's it from my side. I'm going to pass it on to Bober, who's our developer advocate at Pathway. Bober, are you there?
Yeah, hi everyone. Thank you for Anna for the intro. I'm super excited actually being here today and speaking about how to build unified data pipelines with Pathway, and everybody is joining up. First of all, let me introduce myself. My name is Bobur, or you can call me Tiger, which is in English, right? In real time, my colleagues can help you to answer your questions. And if you have any questions, here's my details. Feel free to reach out to me on these following channels. I will be more than happy to help you out with your questions. Here's the agenda for today. We'll start with refreshing our knowledge about what's batch processing or stream data pipelines. I will walk you through the different stages in the unified data pipeline to help us implement production-grade systems using unified data pipelines. And also we'll talk about how you can build your data pipelines using Pathway to create applications, especially AI-powered applications with large language models. Bear with me, and also I will have a short demo at the end. You will love it. First, let me bring your attention to the evolution of various data processing pipelines. When we talk about data processing, this is a concept simply that converts your raw data to meaningful information through one process or multiple processes. It's also well known with ETL. It's abstraction for extraction, transformation, and loading of your data. Is also a common process used in enterprise organizations to deal with a large amount of data. It's a very effective method for preparing like batch data analysis, often requiring days from data capture to business insights. And then it comes with one of the famous data processing pipeline, the batch processing pipeline, which is widely used in this ETL pipeline, in which a lot of data records are collected and stored somewhere in the middle before being processed in a single or multiple operations. An example of projects or systems you can think of using batch processing pipeline, like a payroll, billing systems, that must be processed based on some scheduled time, weekly or monthly or maybe even yearly. And this batch processing, we understood that it's not enough to deal with real-time data and streaming data processing. Streaming data processing that happens when the data flows through our system, right? And our system reacts on this data changes. And this data should be analyzed, and we should take action on the data as the data comes in within a short period of time. Sometimes we call it nearly real time. An example of real world projects or problems that stream processing can solve, like fraud or anomalous detection, or identifying a location of some sort of object in real time, or any sort of user activity we are doing. And then some people also attempted to merge these two different pipelines, like a batch and streaming, into one or two separate pipelines, right? So when we combine these pipelines, where we are trying to merge this batch and stream processing to process some sort of data analytics data in a large-scale architecture, let's assume that from the left side, data events coming from streaming data sources, and then we are capturing them in real time. If data is not required for real-time analytics, we can store this data somewhere for the future use, and we can run next pipeline, second pipeline separately for batch processing. This is not a good approach, as you can see, because we should use two different pipelines. We need to use different sort of tools to bring this picture into the real application. And it also reminds us sometimes Lambda architecture in the data engineering world. Lambda architecture consists of three layers. One is a batch layer, which is a batch processing system. You can think of Hadoop. Below the batch layer is a speed layer, which is a stream processor. And as you can see, also the serving layer, and it's used for more real-time accessing from that storage. Of course, the main benefit was using this Lambda architecture to keep the original input data set and allowing to be reproduced later with a different processing logics. So you can test and debug your application code at speed or in slow mode, like in the batch layer mode, which means you can run one code for both. When we talk about pathway, if you look at the previous slide, like about the Lambda architecture, if you're using a pathway, there is no need to design separately a batch layer or a speed layer, as would be in the case of a Lambda architecture. And the same engine of pathway can provide and process with the same capabilities the real-time data and static data. It allows you to build data pipelines to process your data in the right application layer, which means your data stays where it is, and pathway only runs on top of it. Let's assume that we have some data sources. You can write some code to run this without moving your data from one storage to another storage. And also pathway is designed to handle streaming data updates and making your data pipelines run in real time. And in the middle, in blue, you can see some statistics information. Also runs with machine learning toolkit with various data transformation routines. You can support it. It supports some geospatial visualization. It consists of some useful built-in libraries for other type of data operations. I will walk you through some data operations in the next few slides. But first of all, let me bring your attention one of the important differences of pathway in building data processing pipelines is how you are manipulating your data in static mode or in a finite mode. Let's say when you get really big data, and you can easily switch from static mode to streaming mode using pathway, and you only build your data pipeline once. What does it mean for your code? In this case, if you're just writing one code to run for both and batch processing and streaming, in practice, you need to first provide input connectors to plug the pathway over your data streams. Data streams can be Kafka topics or Debezium that use CDC, change data capture, coming from your traditional databases like PostgreSQL or can be MySQL. And then in the middle, this Python data pipeline runs. And you can also write some Python code that are static, and such as maybe SQL tables. And this written code will be automatically maintained under the hood by the pathway engine, which means whenever new data comes in from data streams, and pathway can update these created tables without additional effort. Once you have this input data processed, transformed, and you applied some filters, you can send result data to the output connectors as an end result. Output connectors also can be the same as your databases, or maybe output Kafka topics, or it can be file systems, any data source you would like to connect your data processing systems. So in the next slide, I'm going to show you also examples of how you can run your code in streaming mode or static mode, because Pathway is, of course, designed to work with streaming data. However, sometimes you need static mode also to be more convenient to test or debug your application. For easy testing and debugging, Pathway also provides static mode to manipulate some static data. As you can see in this table, the summary of main differences in these two modes. For example, under the hood, you are in streaming mode, your data processing runs forever, but in static mode, it automatically terminates once the data graph is built and executed. For more details, you can also check out the website. There are some technical specifications how this graph building process works. I would like to also bring your attention to the next GIF, how it's easy to convert your written batch code, something like that. Assume that you are ingesting data from structured CSV, and now you are writing it just transform data. Maybe you can find some of list of values, and you are writing this code in static mode. And now how it's easy to convert it to the streaming mode. This is with only one line command. As you can see, pathway just dot run. Each update in the input data streams will automatically trigger the update of the whole pipeline. It's more reactive programming. It runs as a loop. You don't have to rerun it again. It runs and reacts on the changes you made in the input data. So,
Bober, I had a question at that image. This is good. This image went really fast, so I thought I'll slow it down a little bit by asking you a question as a moderator. So you can mix and match batch and streaming mode in the same code base. Is that right?
yeah, that's
Okay.
right.
This example you have here, you switch the mode by just changing a flag, I see. Is that right?
And only by changing one attribute, single attribute from static to streaming mode, and you achieve it.
And just for my understanding, static is similar to batch. Is that a fair statement? Like a batch mode?
Yeah, it's batch mode. You know the output result already after one cycle. But when you run in streaming mode, this output can change over time. You never know what kind of output you will get at the end of the cycle.
Got it. Perfect. Thank you. I'm
Yeah.
going to go back into my background here. Thanks.
Thank you. Thank you for the question. Yeah, others also feel free to ask questions. And what other people think about the pathway nowadays, you can write in a Python code, but it's actually developed using Rust programming language. In other words, like Rust streaming engine, which achieves high throughput with low latency. That's why Rust is chosen. And the pathway code also can be tested interactively, which means you don't have to have a complex infrastructure to start with creating clusters. In case of some other tools, in pathway case, you don't have to create anything. You are ready from the beginning. And you can also use the pathway to simply reduce the cloud cost between batch and streaming. So you can also find out some available source codes on GitHub. And for example, if you want to also reduce the number of data engineers or professionals working on a single project or multiple projects, that combines, let's say, both batch and streaming processing, which means you don't have to create two separate teams to manage your data. You can have one single team who has more knowledge on data engineering and data science, and so you can start to build your pipelines using the Python code. You can also check out our benchmarks to understand how we maintain significant advantage in streaming. You can have a look, some benchmarks, comparisons. We now understood the differences between batch processing, stream processing, and how the pathway can switch between two modes. First, let's now dive into more details how actually we can build our data pipeline, right? Building data pipelines starts with how we are ingesting data from input sources that we have seen in the previous slides. When we have SQL or other Kafka topics as an input is coming.
Bober, that benchmark slide has created some interest. So if you don't mind, if you can go back a little bit.
Sure.
just to see what we are benchmarking against with, because Milind pointed out Rust is very interesting. It seems that with our polling we've done with our data engineering folks and data scientist folks, Rust seems to be a preferred platform of choice for data transformation, which is fantastic to hear, which is the choice our CTO Jan has made. And we have, like Bober pointed out, it's a Python friendly interface for our developers. The core engine is powered by Rust. Now, what does that mean? It's built from the ground up, so we don't have the archaic problems Apache Flink has or Spark has. So we're comparing it with Flink and Spark and Kafka streams. So when we do the comparison, we're looking at different modes of Flink operation and streams operation. So when we compare, we're doing Flink micro batching comparison. You see that first bar, it's small. I don't know if you can zoom into that. And then we have Flink streaming mode on the extreme right-hand side. So that's what we're comparing with, anywhere from a 90x performance boost compared to our competitors. So that's pretty much what Milind was asking for, and I just want to make sure we highlight what we're comparing with. And you can continue on, Barbara. Thank you. Appreciate it.
Thank you for interrupting me. I will just and let's say start with ingesting data. We started with right. The Pathway can ingest any stream of data, like a time series or data tables, graph data, external blobs like video or text. And once this data you have, the first thing is we need to map this incoming data into structural tables. So the tables, SQL tables, is easy to manipulate, and creating and removing data rows easy. In Pathway, once we have define the schema for your input models, and this schema will be used to create the tables, pathway tables. So pathway tables has a special APIs. Using these APIs, you can do some data operations. But a pathway can update the results whenever you add the row or whenever you remove the row from the tables. It always reacts on the changes. And these tables also can be created not only from some data sources, also you can create these tables from pandas, popular Python the libraries, or other Python libraries you might think of as a data frames. The next step can be for you to better understand. You don't have to always write some more codes to ingest your data from supported data sources like we have, built-in input connectors. We are supporting, for example, built-in connectors for reading unstructured data, structured data, semi-structured data, also live data sources. We mentioned a couple of times Kafka, or it can be also JSON lines, which is mostly used for some data operations, right? Or if you prefer to have your custom connector, you can also build your custom connector that's maybe more flexible to connect and ingest your data. We have special Python library. Using that, you can build your own extension. And one of the great features Pathway provides is real-time data transformation. As you can see, once we loaded our documents into our table, we can transform these tables into any sort of formation. Pathway also natively supports some transformers like pathway.apply. For example, a function can do some sort of transformation. It's like a changing between rows or the columns, or adding additional columns. And also here some libraries or APIs you can use for dynamically filter your data, or you can use some existing transformer classes to maybe customize your transformation logic. You can even join multiple streams. Let's say you have 2 Kafka streams. You can join these 2 Kafka streams to maybe query some sort of data or transform some sort of data. Maybe you can use some MapReduce to get output and summarization of your input data. Another fact, and that I like here on Pathway, is real-time data indexing, where you can do some structural indexing, also the vector indexing. And what does mean for real-time indexing? In our case, we can do the fast similarity search with metadata filtering, and we can also do similarity search with time filtering using the well-known KNN, K nearest neighbors indexing approach. by constructing the indexes, let's say using generated embeddings from LLM models or any source of input data in real time as data changes. I will walk you through more in details how this indexing works in the next few slides when I'm showing actually these LLM applications that I built that explains how this indexing works even without any vector storage or vector databases. Ideally, we are not storing anywhere this index results because building the index from the input is fast enough and cheap enough to use this real-time index in real applications. After we loaded the data, we did some transformation, indexing, right? The next operation can be sending this data to output connectors. We have a lot of output connector support for now. Here in the picture, I'm showing like how you can use features like subscribe features. For example, you can subscribe to the output stream to send some resulted data automatically or based on the event happened. In this specific example, we are sending some alerts to Slack channel. As something happened, we are sending this alert message to Slack in real time. And here's a summary of built-in input and output connectors, HTTP and APIs. You can also connect your data source as API or streaming APIs. And of course, using the Python custom library, build some custom connectors for your case. So now we understand what's Pathway. Recently, we launched also another open source project called LLM application, large language model application, by using Pathway itself as a foundation to build AI data pipelines that runs in real time. You can also check the LLM application GitHub repo. And these slides also show some of the key features of LLM application in general. Let's say, in addition to built-in connectors, some live data sources, here also you can replay written code for offline evaluation. You don't have to ingest all the time your data. You can also work on the test data or without even connecting to LLM models. You can also test and rerun the same code to check if data pipeline is working fine. Another features we have is alerting system. Let's say if the LLM AI application response are changing frequently, we can also identify some these changes on the fresh information and send some alert messages to your system. And of course, you can also run this LLM application with your local machine learning models. And you can see code-wise how it's easy to build a data pipeline with batch streaming plus LLM-enabled pipeline. Here's a simple Python code. I can zoom in here. As you can see, a few lines of code. I am building my pipeline. And you can say, okay, CSV data is more structured, not a real time, but this can be replaced with other data sources, like as we mentioned, different data sources available. So once you have data source here ingested, you can also always easily transform it. As you can see, we are embedding how this general AI application building process works. And also how easily we are running the same process multiple times using pathway run method. I will leave you also to have a look at the source code. But the fun fact is, if you look at the repo itself, LLM doesn't require like a separate vector databases or any vector syncing tools. Sidestepping also complex, fragmented, typical LLM stacks like LangChain or LLM caches or API builders. And we have already tested out a few use cases. Of course, the APIs can be connected with LLM application. And we are doing a lot of fun stuff, right? I was trying to build one application called Discounts Tracker that's able to find out some discounts from various online markets. For example, assume that you are searching for some specific discounts. You can use AI plus real-time information coming from, let's say, from Amazon products and search for specific shoes or clothes you are looking for. The simple architecture explanation here for this discount tracker application, as you can see, you might have some front-end application, right? You can build it using any other framework like a Streamlit. And as you can see, as user asks, find me some discounts, this request will be sent to Pathway, the backend application built together with LLM application. There are some components also customizable. The most important part happening here on the left side. Once we have some data available and coming from the data sources, as data flows into the system, we are doing real-time indexing and caching. That's the most powerful part of the application. Let's assume that every time we have input data, we need to calculate also embeddings, vector embeddings from the LLM models, right, like OpenAI. And we need to keep this vector indexing somewhere else, like we call vector database, vector storage. But in our case, in Pathway LLM application, it doesn't keep anywhere this indexings, only keeps in the cache resulted vector embedded response to reindex safely after some sort of failure, which means also it's production ready. Let's assume that our running instance somewhat failed in the middle of data processing pipeline, but when you rerun the application and recover from failure of this instance, the LLM application will take the indexing from that failure point, and it doesn't do reindexing from the beginning. That's one of the powerful features. If you'd like to learn more about LLM application and try yourself, this link will bring you to GitHub repository. Can you maybe look at some of the questions we had?
We got a couple of questions, actually 5 to be exact. Let me go through them one by one, Bober.
Sure.
Okay, you talk about persistency, especially in terms of LLM map. There are a lot of questions around LLM map.
Right.
Does that LLM map or does an LLM map need another persistent layer? Is a question coming up from Mudit. Do you
Okay.
want to take that on?
Yep. Sure. Thanks, Mudit. If you're using LLM app, you don't need any extra persistent layer. If it's for story indexing, there is no need to have any storage. And if you're asking if I want to store the data from one stage to another, in this case, yes, maybe you need some data storage to send your data input before sending to the next step. But for the indexing itself, you don't need any persistent layer.
I think it does answer his question. Yeah, so it's a question of whether you want to choose the pathways persistent layer or can we push it to an external vector store, and the answer is both yes. By default, you have a persistence layer. Good. The question around LLM map reindexing, you did mention that there's reindexing happening real time. What happens if the pipeline breaks? Is the pipeline mature enough to handle shutdowns, breaks, stop, restart?
Yeah, this is a very relevant question when you are productionizing your LLM applications. You can build something easy for prototyping. It's very hard to bring it to production because of some security issues or some observability issues or failure issues. To your question, if something bad happens, you will not lose any calculated data, any processed data. Because we have special mechanism that holds your data until this recovery point.
And this is true for vector indexes too, because I
The
think this
same is
context.
vector embeddings, yeah, of course.
Perfect,
Yeah.
perfect. No,
You,
thank you.
you not use
Bober. I think that's what his question was, because there are two questions in sequence. There's a question from Rizwan around, is conversion to tabular schema required for persistence somewhere? So I can only interpret this, Rizwan, as your question being, if you deal with unstructured data, is there a need to convert to a tabular schema? Is that, I'm hoping that's the question
yeah.
you're asking, Rizwan. So if you want to clarify, let's assume that's the question.
If it is question like of using an LLM application or storing the tables, temporary tables from unstructured data, you don't have to create structured tables. Structured tables also can be created from unstructured data sources. Let's assume that we have also unstructured data support. You can have PDFs or other type of PowerPoint stuff. Pathway can generate the tables for you without defining exact structure of your tables. You don't have to worry about specifying exactly what data inputs or data models looks like.
Hopefully that answered your question, Rizwana, if you're still listening in. So I'll just repeat that question one more time just to make sure we've answered it.
Sure.
Is conversion to tabular schema requiring persistence? So any kind of tabular schema, does it require persistence somewhere, is the question Rizwan is asking.
It's a good question. No, it doesn't require. Pathway has built-in memory where it keeps these tables for a while. In Python function, you have some variables. Variables only use it while you are calling this method. And after this method is executed, this variable data, stored data, will be also nullified or cleaned automatically. The same with tables. Tables just stays only for a while until you process some sort of data and it's cleaned up again. Because it's streaming more, as you can think of Kafka topics, right? You are dividing input data into chunks and you are processing each input data chunks one by one and restoring to the same table, how to say. But the table will be refreshed.
I think you hit the nail on the head with that answer, because Rizwan says thank you. Your explanation did help him. Thank you, Bober. Milind, back to his question. He seems to be our number one persona here with the RAG question. So does the RAG app work with real-time stream of unstructured data, which probably is time for you to even pitch your new project, Bober. Anyways, go ahead.
Yeah, thank you. I think, we have still some time, 5 minutes. I can show my sort of cool demo, the monitor itself.
And Milind, if you're listening, he's trying to answer your question through a demo, so bear with us.
Here we go. Yeah, this is the project structure of discounts tracker application. It consists of basically two components like APIs and the UI we built with Streamlit, right? In the architecture, if you have seen it already, and which means if you would like to run this application, you need to have also Docker installed in case you're using Windows operating system. In case you would like to try on other Linux operating system, you don't need Docker. In my case, I'm using just the Windows operating system. And I'm running these two components separately right now. Let's say I am running my first backend application, which is just the main.python file. And once I run my application, as you can see, the application is now up and running here. And it's ready to receive some requests in the background. And I need to open another command line interface to run separate process for my UI application. In reality, of course, you can deploy it together also, but they should talk to each other over REST API or maybe over transport layer, how to say. And now let's run also my Streamlit UI. I think we need to navigate to the folder itself, where our UI code is located. And I can do Streamlit run. Actually, it should be up.python. And here we go. And my UI is up and running. If I follow a link and open that link, you should have that screen. It will bring you this beautiful interface. And as you can see here, 3 actions you need to do to test this application. Like you choose some data sources. In my case, I have 2 options now: Reinforced API, also just API provider that shows some Amazon products in real time. I connected the Reinforced API to get and fetch some real-time Amazon product sales information. Or you can use also CSV. You can also upload the CSV file to get some CSV file discounts from any data set. If I choose Reinforced, now it's already fetching behind the scene real-time discounts. And now I can ask, for example, just find me discounts for Nike shoes. And okay, we don't have a Nike discount, so we can search for any shoes. And let's try that. Here we go. Yeah. As you can see, it found some discounts in real time, actually coming from Amazon, and with the deal price. And you can see also some rating information. And specifically, you can mention also if it's men's shoes, or you can specify also if it's sports shoes, running shoes, or hiking shoes, and so on. And if you navigate to that link, it's working even. If you navigate that link, as you can see, this was the discounts on Amazon available for $39. I found this a really helpful use case because not only for finding out some clothes and shoes, also for stock of options, stock price information. You can also handle the changes over time. For example, I can say, I would like to buy this exact shoes when price drops until $20. You can specify that, and Pathway can start to monitor. When it brings to $20, it can send you alert information. That was actually idle case. I hope that's actually fancy enough, right?
Yeah, yeah, Bober, thank you. I think the takeaways there is you can also, other than dealing with the API, an API which is somewhat semi-structured with a JSON output, and you can either go get fetch the API, or you can index the API depending however you want in terms of frequency. Both of them are allowed. Milind, you saw that demo. Thank you. Appreciate you sticking around. Also, there's another demo which we will launch very soon around how we sync up with a repository, a document repository, a Dropbox repository, for example. You can just point to that. Imagine running your knowledge repository on PDFs. I have my typical use cases is how much tax did I file last year? So it's a very easy to use framework for building LLM maps. And the biggest takeaway again would be it's secure. You can move data from both structured and unstructured data sources. You have a data pipeline kind of thinking and a mindset. We truly believe at Pathway, all the data is, if it has to be enterprise ready, has to go through this pipeline kind of mentality, because you need to monitor it. It needs to be robust enough that in the event you have a problem in the future, you can go retrace and retrigger from that checkpoint. This concept of, especially with LLMs, if you think about it, it's your second source of truth for your Gen AI apps. And when you start keeping things in sync, things will naturally fall out of sync. So this is a problem that we're definitely trying to solve. And these are small examples we're showcasing so that you can take it to the next level. So there's that repository. I'll highly recommend you star GitHub. Please take a look. Our Discord channel is 100% open for any kind of questions, any question for any enterprise use case. Just feel free to come in, say hi. We're more than happy to answer those questions. Our team, who are ex-Googlers and ex-FANG companies, have gone through some of these use cases themselves in different stages of their career. So they would be able to give you some recommendations for sure, even if it's outside our scope, right? So please feel free to reach out.
Yeah, thank you. Thank you, Anup. I think we can finish up with some takeaways. First of all, let me say one thing. Like for me as a developer, because I don't have any sort of very deep background data researching. I don't have any PhD working with data engineering, but I am like a very basic backend developer. For me, it was easy using Pathway. You know why? Because I don't have to know how to build data pipelines. I can just write a Python code. Here we go. And this is my pipeline is ready. Actually, it's working and it's actually solving my problem. That was the experience I had when I was using the first time the Pathway libraries. And takeaways here, of course, as we've seen already, Pathway offers a unified platform so that you can run your code in both streaming and the batch mode. It's also super fast with amazing performance. We saw already some benchmarks analysis. So you can also check it out, how we are putting a Pathway of Spark or the Flink. And also you can use LLM app open source project to build your fancy LLM-enabled applications like I did with the discounts example applications. Stay tuned. Next in the demos. Thank you a lot.
Take care.
Take care all.